In this video, I'm going to use R and RStudio to show you some basic summary statistics that we can do in R. So I'm going to be using two data sets, uspop.csv and bodyfat.csv. So go ahead and download those so you can follow along in this video. The next thing I want you to do is go ahead and make an R script. In this script, I want you to go ahead and type, walk through video number 1, basic stats, right? And then you can type your code and type your comments into your script. Once you have your code, you can use this button to run it and it'll send it over to the terminal. Let me show you what I mean. So this is my script. It's actually written in R Markdown, so instead of being saved as .r, it's saved as .rmd for Markdown. And the way that it works is I have these code blocks that I can go ahead and send to the terminal like that. So I can say run selected line, and you'll see it can set my working directory. Okay, so in this video, I'm going to cover reading in data sets, various ways to subset data, basic summary statistics, so things like mean, standard deviation, range, and summary, and then how to explore your data visually using both histograms and plots, and then testing for a statistical correlation between different data sets. Okay, so the first thing that you want to do is set your working directory. Now, I'll be honest, typically what I do is, because this is a GUI framework and I'm used to working in it, I click Session, Set Working Directory, choose Directory, and then I go ahead and navigate to where I want to be, and I click it like that. It'll again pop up down here, and I can copy and paste it directly into my script. And then I can write Set Working Directory as my comment. Okay, so this is how you can build your script here. When you're done, you can save it, and I can save it in the same folder. So I can call it walkthrough 1 here. Okay. The next thing that we want to do is read in our data set. So we're going to read in that file uspop.csv. And again, I'm going to click run selected line. I can also use my keyboard and I can press Control or Command Enter, and that will also run the selected line. Now what you'll immediately see happen, I'm going to be assigning this to an object data using the command read CSV, and then I'm telling it what the file is. Over here, you're going to see that that data pops up here. I can click this arrow and it shows me that it has two variables, year and population, and both of these are sets of integers. And it just shows me sort of graphically what those are. I can also see when I set my working directory, this shows me my path, as well as the different files in this working directory. So this is sort of how the RStudio environment is integrated in being able to work through things. Next thing that we're going to do is some simple summary statistics. So what you can see here is we're going to use the command mean, and we're going to get mean of column 2. So these are two different syntaxes for doing the same thing. I'm going to do Control Enter, and you can see that here I've got the mean of this column is this large number here. Now I can also fetch the column by using this $ notation. So let me show you how that works here. Mean, open parentheses, close parentheses, we've got our object, and we'll do $. And what you'll see here is that when I press the $, it's automatically going to pop up here in RStudio these two different variables. So I can simply click it or use tab completion. And I'll get the same thing here. Okay. All right. The next thing that we're going to do is some basic summary statistics. So one of them is going to be standard deviation. So this is standard deviation of that population. We can look at the range of years. So this is the first column in our data set, and that's going to be from 1790 to 2010. And then finally, we can look at the summary of column 2. And what you'll see here is that this summary command is going to give us a little bit more. It's going to show us the minimum, the maximum, so the range, but it's also going to show us the mean and the median here. So we get a little bit more information and some quantiles from that. The next thing that we're going to do is we're going to show some very basic exploration of your data graphically. So mean, standard deviation, and range are really helpful, as are the different quantiles, but sometimes it's really helpful to just look at your data. So let's go ahead and look at our histogram. Now if we type it here in our Markdown, it's going to pop up in here. So let's go back to our script, and what I want to do is hist, and I want to do data, $population. And now what you can see is that my plot is actually going to pop up here over in my plots tab. Now if I have my help screen open, I can go over to my console, and just like in the shell, I can up arrow and press enter, and you'll see it by default. When I did that, I was in a different tab. The plot tab came to the front, and then it showed me my latest plot. Now I've run this plot more than once, so now you can see I can use this arrow to go between plots. I can export the plot, save it as image, or copy it to my clipboard. I can change the ratio and update my preview. I can copy it, etc. Okay, the next thing that I want to show you is how to do some very basic plots. So this is just showing us the distribution of population size, and you can see that the majority of the data points are at smaller numbers. But we might want to plot X against Y. So this command, and again, I'm running it from within. So what I'm going to do is I'm going to take this code block and I'm going to copy it into the walkthrough script, and then I'm going to launch it from here. So here I'm plotting the year, which remember ranged from 1790 to 2010, against the population size. Okay, and you can see a steady increase in that. Now this is by default showing a circle, so we can change that character using this PCH or plot character to an 11. So let's see what that does. And that's going to change it to these star icons instead of circles. We can also change the color of the dots using this call equals, and now they're this sort of green color. And then finally, we can use this character expansion or CEX command to say, let's make them a little bit smaller. So CEX equals 1 is sort of at 100%, 0.8 would be 80%, 1.2 would be 20% larger. So this is 20% smaller. And sure enough, they get a little bit smaller. So this is one way to plot data, change the point character, the point size, and the point color. All right, let's return to our slides. Now, we're going to learn a lot more tricks next week about how to make plots look a little bit nicer than this, changing the X and Y axis and things like that. But today we're really focusing on visually inspecting our data and not necessarily making pretty graphs. The next data set that we're going to work it with is going to be a built-in data set within R, and it's called Anscombe's Quartet. What's really nice about this data set is that it shows you that it's really important to explore data both visually as well as using summary statistics, because sometimes simple summary statistics can make your data look very similar even if it's not. So again, I'm going to copy this data over here, and that's just going to show you the table. What I'm actually going to do is just type in Anscombe, which is the built-in data. So any built-in data set within R, I can just type it, and it's going to give me the data. And you can see this is a matrix. There are 4 columns with X data, and there are 4 columns with Y data, and there are 11 rows or data points within each set of X and Y. Okay, so basically we have 4 different sets of X and 4 different sets of Y, and what we're going to do is we're going to use this code to extract the 4 different sets. So what we want to do is we're going to say set 1 is, I'm going to use this to say pull out columns 1 and column 5 and put it in set 1. Similarly, I can use this notation, which uses the actual titles of those columns. So let's show those. you can see when I do that, I'm going to get an object over here called set1. It has 11 observations and 2 variables. I can click on it, and over here it'll pop up. That's my data set. And again, I've only isolated set1, so that's x1, y1, and I have 11 observations. I can use this exact same notation, and you'll see it's the exact same data. Okay. Now, let's see how we want to do this, and this is what I want you to do on your own, is edit this code either using this format or this format to pull out all the other 3 sets of this data. So go ahead and pause the video while you do that. Then what I want you to do is after you've paused the video and you've pulled out sets 1, 2, 3, and 4, go ahead and explore it the same way we did earlier, where we used the mean, the standard deviation, range, and summary, as well as the histogram and plotting x against y. So let's try mean set1 $x1. And we'll just do this for this data set. We can copy that. Y1. Okay. We can do standard deviation, set1 x1. We can do standard deviation of set1 y1. Okay. And we can do summary set 1. And you can see when I do summary of the whole thing, I get both variables, x1 and y1, in my results here. Okay, let's do a histogram of set 1. That's going to be very confusing to it. So what it wants is for us to specify one or the other. So here is for x1, and for set1 for y1. You can see there's more variation in y than there is in x for this particular set. So one of the nice things about R is I can copy all of this and paste it. And let's go ahead and set 1. We'll get pulling it out. We're going to do the mean, standard deviation, summary, and hist. And then we'll do set 2, set 3, and set 4. And then RStudio is a GUI. So I can press Control F or Command F, and I can say replace set 1 or find set 1 and replace with set 2. I want to make sure I'm saying in selection, and then I can click all and it's replaced all 9. I can do that again. This is a nice way. And make sure to click in selection, and then it should be 9 again. All right. Now I can highlight all of this code, and I'm going to run it. Okay, and you can see I have set 1, set 2, set 3, and set 4. And let's go ahead. That's the nice thing about RStudio is that I can drag that up, and I can look at this. So let's look at just the means. So set 1 has the mean of 9 and 7.5, 9 and 7.5 for set 2, 9 and 7.5 for set 3. We're noticing a trend, 9 and 7.5 for set 4. Standard deviation is 3.3 and 2.03. Okay. And then if you remember, so I'm seeing the same thing across all of them. This is the histogram for set 4. And then that's X and Y. Set 3. Set 2, and set 1. So the last thing that we might want to do is plot them against each other. So again, we can do set1, and we can do plot set1 $x1 against set1 $y1, and we can run that. Okay, so this allows us to explore our data visually, similar to histogram, but we're actually plotting it against each other. And we can copy, and we'll compare these between set 2, set 3, and set 4. And since I'm only going to be doing 2 replacements, I can just do that manually. All right, now let's run these. And one of the things, okay, yeah, there we go. So here is set 4, set 3, set 2, something's wrong. Ah, I see what we've done. I knew something was wrong. So what I did is I copied and pasted everything, but I did not change this in the other ones. Okay, so I'm going to get rid of this one because it's a little bit more. So you'll see I'm still pulling out. Let's just pick one, okay? I'm comparing set 1 against itself 4 times because I never actually changed these values. Okay, and just like you get used to when you're doing, a Word document, a term paper, or something like that, get used to pressing Control-Save or Control-S a lot. Do that when you're writing your scripts as well. The thing that I, always, one of my pet peeves is coming to a student who's like almost done with a project and they've still got untitled.r unsaved, and they've got a ton of code. Save that code as you're going. Don't leave it untitled. Call it something meaningful to you so that you can make sure that you have that code when you're done, or if your computer crashes midway through, because this is a lot of work and effort. All right, so let's run all of this again. Oh, it doesn't like the plots that we've done, but we can fix that. But let's see. So for set 4, it looks like we didn't change the Y. Let's look at our data. So we actually have 3 different data sets. Nope, set 1, set 2, and I'm looking here to make sure that our X and Y are changing, and set 4. And the nice thing about this is I don't have to look back and say, what do I need to rerun? Let's just rerun everything. All right, we're getting some errors in our code, so let's try to trace that back. So let's go all the way up here. This is what we got for set 1. We've got our histograms. Set 2. So you notice that set 2 doesn't have a column X1, and it's very confused. So this is one of the negatives of copying and pasting, is that it does come back to haunt you when you don't go through and clean it up. Okay. So for set 1, that was fine. Again, I'm saving, and that's just a habit that I've built up over time. All right, well, we should be running this. I'm seeing a lot less red, which makes me happy. Okay, now this was our last warning message, so we know we're at the right spot. So let's look at those means and standard deviation between those 4 sets one more time. So here's set 1, that 9, 7.5, 3.3, and 2.03. 9, 7.5, 3.3, 2.03. So it is correct that they are nearly identical. 9, 7.5, 3.3, 2.03. 9, 7.5, 3.3, 2.03. Okay, and then let's go ahead and scroll through our images that we made. So first we made histograms. So let's scroll all the way. Okay, so we've got set 1, x1, set 1, y1, which we saw before. Here's set 2, x1, set 2, y1, or y2, and you can see that they're kind of different. Set 3, x3, set 3, y3, set 4, x4, whew, that's very different, and set 4, y4. Now we can look at the plots of them against each other. So here's set 1, y1 against set 1, x1. This one looks very different, and whew, that is quite different. So you can see that exploring our data visually in this Anscombe's quartet example has shown us something very different than our summary statistics, which made it seem like these were identical data sets. But visually, they are not identical data sets. Their distributions are quite different, both in just within each set of coordinates x and y, and when you plot them against each other. All right, so I'm going to clean this up and get rid of these sets, and I'm going to get rid of that data and go back to what we were doing in our R code here. Let me bring this menu down here. All right, here is basically just me doing all of the stuff that we just did. The last thing that we can do with these is we can test for a statistical correlation. So let's come down here at the bottom of our code and can run what's called a core test function. So let's go ahead and explore that over here. Any functions we want to know how it works, very similar to typing man in the function, we can come over here and put it on our help. Similarly, we can put a question mark in front of it and do it here in the console. That should work. Oh, I think it didn't work because it was already pulled up. Okay, so there you can see it pulls it up the same as if I typed it over here. So basically what this is doing is it's taking a set of x and y coordinates. Here we're giving it these. And then it's going to give us some sort of statistical test. So here it's conducting a Pearson statistical test, a product moment correlation. We have a p-value here, and we have a correlation estimate, sometimes called an r-value. We can use this $EST to get the estimate only, so this correlation coefficient here, which is 0.81. Okay. All right, so now, and I'm pretty sure actually before we move on, you can also do this where you type $ p.value and it extracts this p-value that's in here. And you'll notice that this is showing you a summary. This is actually giving you the long form of it where it's not rounded. Okay. All right, so let's switch to a different data set. We're going to go back to that US Census data that we were using earlier, and we're going to do some subsets just like we've been doing. So I'm going to make a new R script. Let's see. Okay. And what I'm going to do is I'm going to take that data. So data still exists. I haven't, gotten rid of that. And that is our year and population. And I'm going to subset it. I'm going to say everything that's before 1900, so data $year less than or equal to 1900, go ahead and store it in a new object called early. And similarly, for everything greater than or equal to 1900, stored in a new object called late. And you can see immediately I get 2 sets of objects. Now, because I made both of them greater than or less than or equal to, I'm going to get 1900 in both data sets. So it's in the late and it's in the early. But this is great because now I have 12 observations in both of them. Okay, so let's return to our slides. The first thing that we can do is get a histogram of each of these. And again, that'll pop up down here. This is the late and this is the early. And you can see that the distribution of population size in US history is very different from pre-1900 to post-1900. Okay, let's go ahead and explore this visually a little bit more using these plot functions. So let's see what this is doing. So the first thing that we're going to do is we're going to run plot year against population, and we did this earlier, right? We've got year here and then population, and you can see that it's going up. Okay, this is going from, this is just for late, so it's going from 1900 to 2010. We can do the same thing for early. Right? And you can remember we did this before for the whole data set. And then, yeah, this is the original one that we plotted before. And so we can compare those, right? We've got sort of a slow and steady and then a so this is the slow and steady, so more of a logarithmic looking thing. And then this one's a lot more linear from 1900 and beyond. Okay. Now we can do that same statistical test that we did, the correlation test. So here we can do the population for late versus early, and we can see that they're highly statistically correlated. But this by default is going to use a Pearson's correlation. We can use this option here. This is very similar to a command line flag. It says method equals, and we're going to change that to Spearman. And here what you can see is that our correlation coefficient went from 0.98 to 1. And we still have a very significant p-value for this one. And this is giving us a different type of estimator called rho instead of correlation, because this is using a different method for calculating that correlation coefficient. So one of the biggest differences between Pearson and Spearman correlation coefficients is that Spearman correlation is based on rank order. So let's look at these two different growth periods. So we've got, let's plot them against each other, because this is what we're doing the correlation of. Okay, so what you can see is that the early period versus the late period, you know, if this, at this point here, it's not quite, I mean, it's pretty close to linear, right? So it's just going up incrementally. Okay. All right, so that's how to do correlation, subsetting, and pulling out different pieces of information. And if we did this and we did $.p-value, we can do that again. We get that here it's giving you an estimator, it's actually 0, and we can do EST like we did before, and it gives you that rho equals 1. Okay, that's a subset of a correlation test. All right, now what I want to do to finish up this video is to return to that, or start working on that second data set, bodyfat.csv. So what I want you to do is follow the same process that we just did for these two previous data sets. Read the data info into an object called fat, pick a variable of interest within the data set to work with further, and then make a new object containing that variable, along with body fat, which is going to be our response variable in this data set. Run some basic summary statistics of whatever variable you picked and body fat, make a histogram of that selected variable and body fat, and then plot the variable against body fat and test for a statistical correlation. So you can pick a couple of different variables and then fill in this table. These are all the variables, so density, age, weight, height, adiposity, neck, chest, abdomen, hip, thigh, knee, so these are measurements, ankle, biceps, and forearm. So pick one of those, and wrist, and go ahead and run this. We're going to be returning to this data set in a later walkthrough video, so you get more opportunities to check this out. All right, that concludes this video on basic summary statistics and subsetting data and exploring it visually using histograms and plotting X versus Y.